One on our study guide, it asks us to sketch a continuous curve with the following characteristics. So, after sketching what our axes might look like, I think the easiest way to begin on this one is by sketching the specific points it gives us. And it tells us that when x is -5, our y is -1. So I'm going to start by putting a point there. When x is -2, our y value is 2. When x is 0, our y is 0. So we go through the origin. And when x is 3, our y is 3. Oh, it might go off our graph here. That's okay. So what we're now trying to figure out is what is happening between these points. Where is our derivative increasing, decreasing? Where does our function flatten out? So we've got some tools to help us with that. We've got a number of pieces of information about the derivative in this case. It tells me that at -2, our derivative is 0. So we know that it's going to be flattening out where we have x at -2. Let's just do a little check off of what we've done. We've done these points already. So we know it's going to be kind of flattening out around x is -2. What else could tell us what's happening close to -2? Well, it tells us that our first derivative is negative from -2 to 0. So that means it is flattening out and then going negative from -2 to 0. It also tells me that my first derivative is positive when x is less than -2. So that means it's increasing to get to this point. Okay, so we're kind of leveling off. There's another bit of information that is useful in this case. We can look to see where it is concave up or concave down by looking at the second derivative. And if we look at where -2 falls in this, that'd be on this interval right here, which tells us that our second derivative is negative, which means it's concave down, which is exactly what our graph looks like currently. All right, so I feel like we've addressed that point pretty well. At 0, our derivative does not exist. So that means we either have a corner or a cusp. So we need to take a look at what else is happening around 0. So we can look at our concavity and we can look at our first and second, or excuse me, our first derivatives. Our first derivative says that to the left of 0, our derivative is negative. So it is continuing down until we get to our point of 0, 0. Okay? It also tells us that to the right of 0, our derivative is positive, so it bounces up. Okay? If we look at our concavity, the second derivative, it tells me that to the left of 0, we are concave down because our second derivative is less than 0. It also tells us that to the right of 0, we are again concave down. So we've taken care of that. The derivative at 3 is equal to 0. So again, we're leveling off. We don't really know what's happening to the left or right by looking at that. But if we look at more information on our first derivative, we see that from 0 to 3, our first derivative is positive. Okay, so it's increasing as it arrives at this point. We also see from 3 onward, it is positive. So it looks like it levels out and then continues up. And our concavity information tells us that from 0 to 3, we are concave down. Okay, so we can kind of continue our picture here. Concave down looks like an upside down parabola. And then when x is bigger than 3, we are concave up. So we're starting a right side up parabola. Check that off. All right, let's see. What other information have we not covered yet? It says that our first derivative is negative from -2 to 0. We've covered that. It says our first derivative is positive for everything below -2. So that means from 5 to -2, there are not going to be any points where we level out or turn to negative. But let's take a look at the concavity from -5 to -2 to get a good picture of what this is doing. From -5 to 0, it says we're concave down. So this is going to continue to kind of look like that parabola, that upside down parabola. Okay? And it says that, let's see, is there any information about what happens to the left of -5? So it says that our derivative to the left of -5 is still positive. Okay, still positive. Do we know anything about the concavity? Well, when x is less than -5, we have it concave up because our second derivative is positive. So we're going to look something like this, where we have a positive slope and we're concave up. All right, check that one off. Ooh, at -5, our second derivative is 0. So that means we're switching from concave up to concave down. We've done that already. Check. Our second derivative at 0 does not exist. We have a cusp there. Check. Our second derivative at 3 is also 0. So that means we're changing concavity. And here we are going from being concave up, or excuse me, concave down to concave up. So check. And we've taken care of the concavity on this whole interval.